resistance. Periphery to the outside, okay? So think of everything that's coming off of the heart, all these vessels, okay? And all of these vessels are a tube, okay? Anything that is going to oppose the flow is going to affect my blood pressure. Some of it, well, it's just normal, okay? Other parts, well, might happen over time, might happen because of our diet, might happen because of our lack of exercise. Lots of things can happen based on what is found to the outside of this heart. One of the things that we encounter, what is the viscosity of the blood? We've talked about viscosity before. If you remember, that's the like how fluid something might be, okay? I always think of motor oil, you know, because motor oil is this like slippery substance, okay? Has a slow flow to it. It's very viscous because it needs to be, okay? And so for blood, that thickness of it, and it's rather thick, believe it or not, but has a normal thickness. We have a norm that exists. The reason it's thick is mostly due to plasma proteins, for example, the ones that will transport hormones, okay? And then, of course, the red blood cell count, because we have a norm of the value for the red blood cells. And then, what's the length of the vessel? Now, if you look at the makeup of our vessels, as we enter the heart, okay, we have different lengths that are existing. So, the longer the vessel, all right, if it's this long and the blood flow starts, the longer that vessel, the more it's getting, well, the friction. And that's because of the structure of the vessel itself. Okay? The vessel itself on the inside actually creates friction. What is the radius? We know that if we start out big at the heart, we start out at the big, go from big to small to small to smallest, and we start out smallest to small to big to biggest, okay? So that radius affects the flow. The smaller the radius, the slower the flow. The bigger the radius, the faster the flow. These vessels also have the ability for vasomotion, meaning they can constrict or they can dilate. When they constrict, they're moving the blood flow back to the core of the body. When they dilate, they're moving it to the extremities of the body. And under normal conditions, they're contracting and dilating all the time. All right? And then they will change based upon demand. What is going to be the demand? Do I need to go run the race? Meaning, I need to increase the demand of blood flow to my skeletal muscles. Or am I going to sit here in bed and watch TV? To the core. So they will meet the demand for the blood flow. Under normal conditions, as the blood is flowing through the vessels, it's called laminar, in layers. And what this does, the layer that is closest to the wall of the vessel is the slowest layer. The layer that's right through the middle of the vessel is the fastest. If there's anything on that vessel layer on the wall, for example, plaque buildup, is everybody familiar with that? Okay, where, you know, they tend to relate it to like cholesterol issues and stuff like that, okay? And wherever a plaque might be found, that slows my blood flow in a lot of ways, in all reality. And sometimes they're found very close to the heart, on the heart, okay? And you hear people say, oh, well, they had to put in a stent, for example, or they did the balloon. Ever heard of that? Okay. They basically simply went in and stretched open the blood vessels to increase the blood flow to the areas of the heart, in the hopes that, you know, if the person, a lot of times lifestyle is a factor, change their lifestyle and it doesn't build up again. So, you know, there's lots of reasons why. But these factors will affect the movement of the blood and therefore affect my blood pressure. Now, something that we're going to see, because we've kind of mentioned these today, all right, one of the biggest factors that are going to control or affect my blood flow and therefore other pressures are my arterioles. Now, if you remember, that means the very small artery before we hit the little capillaries. And the reason for that is we're going to see that we're going to have them making their way across, like directly through the middle of this capillary bed. They are very high in number, because I don't even know if anybody has a value on how many capillary beds we have, and they're very muscular. And then we've got the sphincters that are going to be found just right here near these arterioles on those capillaries. The reason that that controls it, okay, well, if the sphincters close, blood is going to simply bypass this bed altogether. If it's open, the blood's going to flow into the capillary portions, okay? And that has an effect over blood pressure as a whole. Okay, we'll stop right there for today. We'll start that on Thursday.